Dr. P. Vlbjcas, Site Analytic Engineer, Redstone Data Scientist, to deliver today's technical session. Ma'am, we are honored to have you with us today.
Hi everyone, very good afternoon. So I'm so happy to stand in front of you for the part of this faculty development program. I really need to thank my I really need to thank Nadia ma'am for giving me this opportunity because I'm her student. I'm alumni of this college 2016 passed out batch. So ma'am, thank you so much for inviting me here. And okay, so we are going to see what feature selection, dimensionality reduction, and imbalance data modeling. So I know this is after lunch, so you guys feel a little bit sleepy or bored. No worries, guys. You have to adjust. It's all theory-based items only, so we don't have any code or to show like what it works and how it works. So let's see, little bit I will try to keep you engaged by real world examples. Okay, however I can, I will do my best. And thanks for all the faculties here. Thank you so much, ma'am. Okay, so for over next an hour, we are going to see about this three topics. So this is like a major and an important concept in the healthcare AI. So not healthcare AI alone. So everywhere, wherever you develop an AI model, these three features will really help you to analyze and how the data gets filtered. Then only your AI model can be a perfect or the very quick response you will be getting. For example, so if an patient is having a simple headache and doctor is giving a report to like 500 blood test report, is it a valid one? No, right? Because just a simple headache, first doctor has to check with the patient like, did you have any cold food or what is the problem? And second, he will analyze and based on that he will treat the patient. But the same way, when you feed the AI with multiple data, it could not diagnose the better result. So the same thing in an ICU AI engine. So as we are talking about healthcare topics, so I am relating with an ICU AI engine. So if you have fed it with a multiple data, a redundant data, or a noisy data, what happens? The system crashes. The latency will be spiking here and there, and you will not get a predictive result. So it will be failing there. So the same thing. So you have to maintain the constant data and the data which is really needed to train the model. So that's where we apply this feature selection. So feature selection is nothing but fetching or extracting the related data from the original data. Instead of putting every data, instead of uploading multiple files into AI and checking like just I need this requirement, this is my code, give me an output, it will not give you. It will give you something whatever it have been trained. So make sure you insert the proper data to the AI model so it will give you the exact result whatever you expected in a very short time. So another example is like there is a data matrix. Okay, there are like 25,000 genes of 100 patients in a data grid, and where 25,000 into 100 is like 2.5 billion data. So is it possible to go through all 2.5 million data and analyze that information is stored majorly for the purpose of scientific information for the doctors and the experts to do a research and identify what caused the issue, what made the people to go sick, and what treatment is better for the treatment. So for that diagnosing purpose, they are maintaining this kind of a data grid. And with 2.5 million data, it would take an hour or also it would take a day to find out the exact result. So in that way, we have in a data grid, each cell will be having the measurement of that particular gene of that particular patient. And secondly, it will be having how many active cells are there, how many copy of genes are existing there. So in that case, it is not possible. What is the reason to fetch all of this data? Only two purpose of this. One is to find out the exact medicine or a treatment for the cause of illness. Second thing is to differentiate between the healthy people and the unhealthy people. So only for this two purpose we are fetching this kind of lot many data. So in this process only feature selection comes into picture. Okay, so moving on to next slide. Yeah. So why dimension harms the model? Dimension is nothing but the data grid with this 2.5 million data. Why it harms the model? The reason is like as mentioned saying you will not get a clear accurate result. You will not come to know who is healthy people, who is sick people, because each gene will be different from one another. So make sure you maintain the proper data, and also what it happens like it starts to the AI model just starts to memorize the superficial data instead of the exact biological factors. So that is the purpose why it harms. And second thing is like why feature selection solves it. So when you remove the noise model, no, it's okay. So if you see like first if a patient is coming and if you are asking him to do a multiple test and you are telling him you are not well or you are sick, what happens? You will need to spend most of the money on taking a blood test or some other test. So that is one. So this AI will predict accurately what is the issue in the patient. So the cost reduction also reduces, and then the burden between it's not just only about computer, it's also about UI when it comes to an AI, right? So that will be reduced here. That is why we make sure that the feature selection should be applied for all your AI model. There are three methods like filter method, wrapper method, embedded method. So what is filter method? The feature selection we apply called a principal component analysis. That is nothing but you are going to fetch or create a random variable from the original data. So that is what the PCA does. And the same way filter method applies. So it is a statically independent method. It is not dependent on anything. It fetches the features and runs properly and take the set of which is really required. And when it goes to wrapper method, it eliminates what are all not required. So yes, from 25,000 data, you need to apply this filter method and it reduces to 10,000 data. And by applying the another method, wrapper method, it reduces to 200 data. And by applying the embedded method, it reduces to 10 to 15 data. So that is how when you reduce the data model from 25,000 to 15, if you are asking a patient to take or evaluate with this 2,000 records, that doesn't make a sense, right? So when you run a full layer of 15 or 10 genomic layers, that will be very accurate for the patient to find out the result. So that is all about these three layers. Yeah. So the same thing. I have to only one example so that whenever I change the topic, the example remains same so that you can easily correlate with that. So here if you see like 20,000, we are again trimming from 25,000 to 15. The reason is like we apply a multiple hybrid pipeline for this. Okay, from SRE perspective, we make sure that the pipeline remains stable and it does all this thing. So I am just correlating with my work, what I do in an IT. Okay, so if any server is down or any application is down, it's a big impact, right? So guess like if Google goes down, what happens? You all will be tense. You all start raising an incident that Google is down, Atal network is down, right? The same way the project I work is very high level. It is used in an White House project. Okay, so what happens when the UK goes down? The same what will happen when my application goes down. So that's why we make sure that we maintain the stability for that, and we calculate all the SLO, SLI, SLAs between the application through that. And that's how, like, when an efficiency, while you're trimming using the pipeline, the healthcare AI just simplifies the large data into a small data which is really required. Okay, so that is what we are discussing here. Yeah. Next is dimensionality reduction. The same thing as you seen before, we have applied different kind of methods like filter method, wrapper method, embedded method, and here also you will have some non-technical linear methods over here. And if you see, like, it is giving a 95 percentage of variance retained data. So before, it was not easy to diagnose the diseases or something, right? You want to go to doctor, and even doctor is sometimes you want to go to doctor, and doctor also will sometimes unable to identify. But now you have everything. Even if you google for everything, it will just tell if you have a cancer. Even if you type I have a headache, it will tell you have a cancer. So the same way, AI should not feed with a random data. It have to be very. So make sure that you have the accurate data for the AI model to be trained, as it's a neural network based stuff. Okay. So yeah. So if you see here an inverted U, right? See that it is just a feeder with 5 features. So the data is not available. It is just a less data. So the graph shows from the start of 0. When you increase to 10 or 15, the graph gets little bit high. The reason is like it was able to identify something. And when it goes to 20 to 25, you might see a 90-degree, which is 95 percentage of accuracy, and that is called as sweat spot. And if you go ahead with increased number of hits, it's not possible. So the same thing, AI will not be, if you just give like 1,000 files and you ask it to read and identify or diagnose, it will unable to do it. The 25 also should be the very particular item which is really request. Instead of suggesting a AI to go ahead and read all the project, you can just tell the AI, this is the project and this is the file, read this and give me the data. So that is how the AI looks for, and you will be getting the accurate result only when you try this kind of methods. Coming to TSNEP, so as we discussed, right, before, we had 3 different methods for filtering. The same way, this method is like TSNE is nothing but a distributed stochastic neighbor embedding, and UMAP is uniform manifold approximation projection. So both are similar. How it is similar is like you are buying a car. Okay, so what you check on the car when you buy? You check a color, length or height, width, and what is the power of the engine, horsepower, so on, right? The same way, so it will be confusing. Automatically, when the engine power goes, or the horsepower also goes high, right? So it doesn't give the exact data what you are looking for. So in that way, it comes into picture that principal component analysis. That is the first component it creates from the random variable. What it does is like it just it also spread the data points across the angle. So wherever the data points are more and bunched with that angle, means that it doesn't have the useful information. So from there, you can find it out which is really required data. By applying this only, you can identify which is the correct data. Yeah. Autoencoder is nothing but like learning a neural network, and it takes the noise, it converts the noise into the clean and fast and trustworthy AI agent. Within that, it will be helpful. Yeah. So one thing you want to identify is like, before creating any AI model, the data algorithm should be always greater than the algorithm complexity. So the data quality is important before creating an algorithm. So make sure you maintain the perfect data quality. And in short, to be answered, that future selection is nothing but it just turns the noisy data into an clean, fast, and trustworthy AI agent. That's all. A simple note on feature selection. Yeah. So when it comes to imbalanced data handling, you guess like there are like 10,000 patients, okay, where 1% of person is being identified with a brain tumor and 99% of people are healthy. And I'm writing a small script telling that identify the healthy person. What it does, it gives me 99% of result. Does that matter? But it have missed that one patient of 1% of patients who had a brain tumor. So that doesn't make sense because that 1% is also important where they are being analyzed with the brain tumor function. So that is called as paradox concept. Yeah, the same way as we saw before, no, TSME, UMAP, and autoencoder. The same way, SMORE technique, and then the Tomac links are being available here. So SMORE technique is nothing but it just used for group of bunching cells, and it is a straightforward. It is a relationship between the sick people. So first it fetches the neighbor sick people and it just draws a relationship between them. If it is not properly available, then it goes with the bunch of cells. So the main purpose of this is to handle the bunch of cells. And Thomas links is nothing but it just removes the or cleans the boundary of the obstacles we see. So after clearing, it will be help to create a crystal clear variable for us. And this is some of the evolution where true positive divided by true positive plus false negative. So these are the formulas we apply to how to calculate that. And yeah, so coming to real world examples. So before early stage of heart attack is very tough to identify, but now it become very easy. And also what it does is like you can separate easily the healthy and sick people from the by using this AI agent. So sometimes the manual prediction also goes fail so that people will be suffering a lot. So instead of that, this agent is now able to accurately get a 28% of result. So that is one thing. And second thing is like cost learning. So cost learning is nothing but you are telling a sick people that you are healthy and you are telling healthy people the sick. What happens? False negative, false positive. So if you tell a healthy people you are sick, what happens? They get afraid. They spend a lot of money to cure the disease. They go for multiple round of blood tests. So those things happens, right? So that is also waste of thing. And when you tell the sick people as healthy, what happens? They doesn't care about their body. They go ahead as whatever they are doing, and it might lead the life loss as well, right? So that's what the AI is doing. So we have to make sure when it comes to healthcare AI, very consciously we have to create it. And also, the doctors create or they treat the people just blankly, they could not go with this model because it is not ethical for their profession. So they need to diagnose, they need to understand, they need to train the AI by lot of data, and then they can decide like which is really required and not. So that is one thing here. Yeah. So another thing is like from SRE perspective, as I mentioned already, we have to keep up the pipeline stability. We have to maintain that so that it will never affect or it never goes down at any cost. Because in emergency situation, every minute, every second is made as a count, right? So in that case, if your AI model is running for 4 to 5 hours, what happens? It's waste. A patient in a serious condition and you're waiting a AI model to give you a result, it is completely waste, right? So the AI should be giving a result in a fraction of seconds or fraction of milliseconds. Then only it is considered as an AI is in use. Yeah, so any other questions here? Yeah, that's it I have for today, guys, about this. So I know that it is very raw theory, fine. So just I'll start sharing my experience, and I have one another code to run, like how the AI predicts the nearby values, so that it will be easy for you to identify. And I hope you all are third years here, right? So Python is the most important language in upcoming days, guys. So make sure you learn Python. You know the logic of the Python, because all companies are implemented with AI tools. So you want to know how AI is do. You know that layoffs are happening across all the companies. The reason is like AI. Yes, AI is taking our jobs. The reason, if you want to, if you are able to create AI, then no one is going to fire you. Right? If you are not aware of AI, or if you are not about handling the AI, then it's waste to recruit you. That's what the recruiters feel. So I request you all guys to learn Python, understand how the Python helps the AI. So entirely everywhere AI is developed using Python. So Python is going to be a major language for you. So make sure you learn about that. Okay. I will just show you. Okay, just quickly for the diversion purpose. You can see here, right? This is a website, okay? Just helping you to understand like how it does. So here you can see, right? It's a website where it helps to understand about AI stuff. If you are adding some sample images here, okay, I'm just opening a webcam. See, this is the focus light I'm taking, okay, hold to record. So it is a picture of that light, right? The second, I'm giving a webcam, and I'm just giving, if you don't mind, okay. Okay. So I'm just holding a mic and taking. Okay, so two pics have been taken, and just if you click on train model, it's training. Yeah. So you can see here, right? So on preview side, the camera is on. So when I show as this, it is showing class 2 as 99% of accuracy. You can understand, right? So as the class 2 is having the desktop as a background, so that's why when I show it as desktop, it is showing like 98%. The bar is keep on increasing. So when I keep the mic, it shows 100%, right? So here nowhere we have saved the data, nowhere we have uploaded the files. It's just a webcam open, we are showing. We did not save it anywhere, but it was able to understand. The same thing when I just turn to focus light, you can see, right, class 1 went to 100%. So this is how the AI predicts. This is how you need to get the accurate result when AI, you are modeling the AI. And another one thing, I'll show you a code. Okay. So if you want to practice a Python code, you don't need to go and install whatever you want in a machine. It's a runtime compiler on an online website. You can just execute and run to get an output of that. Okay. So I have code already. For an example, I have got it. So I just ran, I got output. So what this code is doing? This is how the AI code will be written. So one thing is like you're going to train the data in the AI. You have to train the data by telling that these are the alerts. For example, I am working on SRE side, right? So I want to predict is there any outage that caused the alert or any alert that caused the outage. So I have a database where the alerts will be stored and I have an outage which is stored in a database. What happens? How I can correlate using a Python? What I tell is that go read the outage data available in the database, see and come back and go to the alerts database and check which alert caused this outage. How it will check? First it will check based on the timestamp when the outage occurred. If the outage occurred on the Monday morning, it will first try to get the Friday evening to, it will start to take the data from the alerts table. So Friday evening to Monday morning. First it will fetch. So for example, you have fetched 100 alerts. How you can sort it out? How you can select that this particular alert caused? So the next thing how you train is like correlate with the words. So in outage, if there is a description like there is an downtime in IWAP application due to a database server, something that. So first it will identify, okay, because of database only the outage is created. So go to alerts, in 100 alerts, check for the database word and it will fetch the database alert. So from 100 to it reduces to 10 or 20. And from 10 or 20, it is going to check like whether the Tampa or which region is experiencing. In India, is there in an outage or it is in US? If it is in India, go back from the 10 filter it was only the India outages. India alerts. So that's how. So from 10 to 5 and 5 to 1 is very easy to predict. So you have to train the AI model. AI model just like that can't understand. Okay. So multiple data are fed, so the system crashes. So you have to train the data. So in the code you can see, right, it is a very simple code. Training the data where this 140 represent the gram weight of that label called apple. And 9 the second is nothing but the scale and a rating, like from 1 to 10 we have been rated it with. So for example, we have trained with 6 data here and go here. Here we are designing a simple function. What we are doing is like you are fetching that particular value. Okay. So as we see here, 0.1, 0.2, 0th place and first place is what we are considering. Go back here. This is considered as 0.1. This is considered as 0.2. When it is 0th position, it is 140, and in the first position, 0th position of 0.2, it is 130. The same way for 9 and 8. So that formula we are applying and we are doing it with a multiplication of 2. The reason is like you need to get the positive value instead of negative values, and you are also taking a square root of this. So when you take, that value will be stored here. And here what we are doing is like, here is the major prediction function we have written. So we are fetching a new value, new weight or new thing, what we are training that particular model. Okay. If I give some data, it needs to identify above in print data what is the nearby value. That is what this concept is. Okay. So here just we are initializing it and we are just taking for a negative or positive values. And here we have written a for loop where you iterate to each and everything and you identify whether the value what we fetch is less than the nearby value or not. In above we have 140, 130, right? So if I'm giving 120, it should come between 140 and 130, right? So that calculation we are doing out here. Yeah, so here is what this is just manually given, so I'm showing you. So here I have given a test cases like 135 with a 8.5 rating and 175 with a 2.5 rating. So here just a printing statement to print an iterate based on the test case input. So if you go back, 135, 8.5, 175, 2.5. So 135 lies between these two, so the label is named as apple. You can see it out here, the output. And the next thing is like 175, it lies between 160 and 175, and the smoothness is also between 2.5 and 3, so it lies and comes like prediction as orange. So this is how the AI model will predict each and everything. So make sure you train the data properly and so on. So this is just an example for you guys to know. When it comes to my work, you can see here, right? Again, I am training the data with all these values. This is called as CPU usage, memory usage, network latency, and this is called as desk room temperature. So desk room temperature is really not required because if there is a server, if the server goes down, what happens? It's a background, it's a platform related, right? In fact, you can see like UI is up or not, it might be up, but it doesn't work until the backend is up. So if the backend server goes down, entire thing will be collapsed. When you take it as company level, it will be a very much big loss for the companies. I think in 2012 or something, leap, right? Leap year means 1 second it will be extra considering the regular days. So that for that rotation, earth rotation purpose, I don't know the company name exactly, they have introduced that leap count and they have just increased 1 second, not 1 minute or something, 1 second. So after taking it to 1 second, what happened in the Linux server, everything is purely based on timestamp based on that location. So either it might be in Tampa, it might be in Twinsburg, it might be in Sacramento. So irrespective of everything. So 1 second after increasing, what happened? Hundreds of data was flowing. Immediately the same. 12:30 again repeats with 12:30 after 60 seconds. So again 100 of the entire application crash, the entire Linux server went down and it was like huge $1 million loss there because of that 1 second. So we make sure that CPU, memory, network latency are maintained in a backend server. So here are the live count, and then if you see only one is critical outage, which is close to 100%. So there will be a minimum target of 80 or 85 less than 70 in that case for CPU usage and memory. But when it go to 98 plus, what happens? It is a critical event alerting that the server will be going down. So when it happens, the same kind of calculation we are applying here, all the things are same. So if you scroll down, we are taking the live metrics data. So here are the calculation for live metrics data of that particular server. So when you take a live metric data, it have resulted with a 95, 92, 400. So it checks whether it is healthy or critical average. So when you compare it, it goes to critical average because it is close to critical outage. So because the value is 95, 92, 435. So this is how the AI code will be working, and it will immediately alert the persons who are working in an incident management, telling them that the server is going to be down. So make sure you appropriately bring it up before any losses or outages occur. And that is one thing. And here if you see the last value we have given as a room temperature, right? So room temperature doesn't give any sense here, because if an Kubernetes goes down, if an AWS server goes down, what happens? It is going down because either of a multiple data or because of some other issue, not because of room temperature is high, room temperature is low. Because of that server went down, there will be no cause of that. Okay, so that is considered as a wrong data. So that way we are slicing here. You can see, right? In Python, colon 3 is considered as slicing, which is only fetches the index value of 0 and 1 and 2, not the 3. That is where the room temperature is ignored. Okay. So this is what a Python code. So just to make sure that this is all related and this is how you need to design. Any other things you want me to cover? You can ask any questions not really related to AI, but other than that also you can ask. ஏதாச்சும் வேற கொஸ்டின்ஸ் இருந்தா நீங்க கேட்கலாம். இதுவுமே லைக் ஐ மீன் ரிலேட்டட் இன்டர்வியூஸ் ஆர் anything related to IT sectors. Okay, thank you so much, guys. Thank you, ma'am.